Hello guys, today I'm going to teach you uh, about the next topic. Before we till till now, before we in our previous video we've discussed till now relation concept. We've discussed. Sorry, just wait. I have to erase it. Till now we have discussed about relational concept. Now we will discuss about some mathematical foundation which is required. Okay. Till now we have discussed about the relational concept. Now see the next our concept function. What is a function? It is a special type of relation. It is a special type of relation. Now look at this example. Now look at this example carefully. We have two sets A and B. We have two sets. In A sets we have four elements. 1, 2, 3, 4. In sets we have only three elements. So how the function is defined on this? There is a mapping. There is a mapping of an element such that, like now look at sorry. Now look at this. F of A. If I will put F of A is equals to F of A is equals to F of B. There must be each unique value of A. We get a value of a B corresponding to this A value. So now look at this. One element is mapped with A. Element number 1 is mapped with A with the set of B, and the third and fourth element of a set A is mapped with the C element. These two element of A is mapped with the same element of a B. It is possible in a function. Now look at this point. No one element can be mapped to two objects. No one element can be mapped to two objects, while the two element can be mapped to a single object. This is just wait. I have let me change my pen color. Okay. Now these elements we will set it to as a object. What it will? We will say it as a objects. Okay. We will see it as a object, and this is we will say as a our elements of a set A. Element of a set B is said as to be objects. It is what? It is a element. It is a element of a set A. So now here look at this. 3 and 4th element is mapped to a same element, which is known as a C here. Sorry, which is known as a C here. Just wait. Okay. Now which is known as a C here. So now look at this. Just scroll down. Okay. Now look at this. Sorry. Now look at this. There is an element AB such that this is a symbol of belongs to. This is a symbol of. This is a symbol. This is a sorry. This is a symbol of. This is a symbol of belongs to. This is a symbol of belongs to. Now look at this. There is an element AB belongs to relation R. There is an also this is one pattern we have. Sorry, this is one pattern we have, and this is another pattern we have. AB belongs to R, AC belongs to R. What it means? It implies A is equals to A and B is equals to C. So it implies A, B is equals to C. This is the symbol. This meaning has a for all. For all, A belongs to A. For all. For all A belongs to A, for all BC belongs to B. It means BC element is belongs to set B. These two element is belonging to the another set. What its name is? Its name is B. And these two element is belonging to the another set, which name is said to be as a A. This combination of a different element of a two set is belonging to a relation. It is a part of a relation. It is these two element A is belonging to set A. Now look at this. We have another concept called a let's scroll down it. Okay, there is another concept called a graph. What it is? It is a set of vertices and edges. It is a set of vertices and edges. Let me write it right here properly so you can understand it very well. Just wait. Okay. Okay, I have to write it here. There is a concept called. Just a second. Okay, it is there. So it will be visible to all of you. Larger my font. So this is vertices and edges. Now look at this. What it is? Graph is a set of vertices and edges. What is vertices and what is edges? Now look at this example. We have the okay. Let me change the color of my pen. We have this example. This is called the vertices. We have total 4 vertices here. I am just pointing it in a very spread manner so you can understand it. This is a what it is. It is shaded. It is shaded. It is shaded vertices. It is shaded. It is shaded vertices. It is shaded. Okay. It is shaded vertices, and this is known as the edges. As we can see here, each edges is a direction. This is a direction in the right side. This is a direction in the downward. This is a direction at the left side, and this is a direction at the upward side. So what will we say it? Instead of saying simple edges, we will say it directed edges. What it is? It is a What it is? It is a directed edges. Now there is another concept called a sequence. Now look at the this concept sequence, how it is different from a set. There is an just now look at this example. For understanding anything, we will understand first an example for its better understanding. So now look at this example. We have a sequence of an alphabet. It's a uppercase alphabets A, B, C up to Z. So this is a sequence of alphabets. There is a sequence of a Fibonacci series. Ordering is very important. Now look at I have to write this point just in the just I have to change my pen color. In sequences, okay. In sequences, ordering is very important. Now look at this part. What am I saying? In sequences. Okay, now look at the ordering. What we have? Just let me take pen. Okay. Now look at this. In sequences, ordering is very important. Inside, ordering doesn't matter, but in sequences, ordering is very important. There is a sequence of Fibonacci number. What is Fibonacci number? There is a 1. Sorry, it starts from, now look at this. It starts from 0. Then there is a 1. we add to these both number together, 0 plus 1 1, we put here 1, then again we add to previous number, 1 plus 1 is equals to 2, and then we again add with these to previous number, 2 plus 1 is equals to 3. Now then we again add these two numbers, 3 plus 2 is equals to 5. This is in a series, it's going on, it never stops, it's going on like this. This is a sequence of Fibonacci number. If I will just now look at this an example, if we say this is 0 1 1, this is 2, this is 2, this is 1, and this is 2, this is, if I will put 5 before 3, then this is the not a sequence of a Fibonacci number, because Fibonacci number what it is, it is current number is the sum of the previous of its two terms. So 3 is not the sum of its previous two terms. As we sum it, 5 plus 2 it equal to 7, but it is here 3 as it is not a sequence of Fibonacci number. So we can say it is a set of a number, but it is not a sequence, because in the sequence ordering is very important. Now look at this part. What am I saying? I am emphasizing on these words. Ordering is very important. Now look at this. There is an alphabet A B C D to up to Z. There is an alphabet. It's a reverse alphabet Z by up to A. So here ordering does not matter in the case of set. Ordering does not matter in the case of set, but in sequences ordering it is matter. Now look at this sentence. Sequence, we can think of a function from natural number to objects. What it means? Now move to the next page. What it's saying? Now look at this part. Just wait for 10 seconds. Okay, continue it. Sorry. Now look at the whatever I said in the previous statement. Sequence, we can think sequence as a objects and of a natural number. There is a natural number from 1 to 2, 6. We know that the natural number starts from 1 and it's going up to infinite terms. So Fibonacci number is it is an object, like we can see it is a natural number. There is a set called it is A, and there is a set called it is a B. So now look at this part. This is the natural number and this is the Fibonacci number. So what it's saying, this is the object where A is mapped with an element of a set B. What it is, we will see it as a object. What will we see? What will we say? It is as a object. So natural number is mapped with the Fibonacci number. So this is the object. Repetition are allowed in sequences. Now look at this part. Sorry. There is a word called repetitions. Sorry. So word repetitions. Repetition are allowed in sequences while it is not allowed in the case of set. Repetitions are not allowed in the case of set. Repetitions are allowed in the case of sequences. Now look at this example. We have A, B, C, D. Then again we have A, which is a repetition. Then again we have B, C, D. So we have again repetition of an 4 elements of its previous version. Then again we have repetition of B and then again we have repetition of B and A. So now our method, our mathematical foundation ends here, which is required to understanding for better understanding the each and every concept of our theory of computation. Whatever coming topics in their theory of computation subject, we required only this mathematics, so we have to revise it once. Now look at our next. Now look at our another topic, which is known as alphabets, distinct languages, and grammars. Now first look at what is formal languages or linguistic. Linguistics means it's a dictionary, meaning is relating to a word, or relating to a languages, because a language is also consist of a word. Sorry, what its linguistic meaning? Now at this part, straight. No. Okay. Now what it is? It is a formal languages relating to language. Okay. Now look at this. Now look at here. What am I saying? I am saying linguistic means relating to a languages. Its dictionary meaning is relating. Its dictionary meaning is relating to a language. We have already told you about it. If we said machine, automata, or a model, these three words are synonyms of each other in the reference of this subject. In this subject, theory of computation, there is a concept called an alphabet. What is an alphabet? Alphabet is a finite set of symbols. Symbols can be anything. Just now look at the examples. We denotes the alphabet by these symbols. It is a sigma. So alphabet of an English language, what it will be? It will be A, B up to Z. It will be available in a uppercase, or it is also possible we have like this in a lower case. It is also possible that we have in a like this in a English language. So it is up to Z. So there is an also alphabet of a binary number. What it has only two symbols, 0 and 1. If we talk about the ternary number, then it has only three symbols from 0, it's 1, and then 2. It's all about the ternary number. There is also octal number, which have a symbol from 0 to 7. There is an also we can say alphabet of an hexadecimal number, which has a symbol from 0 to F, which we will have a symbol from 0 to F. So there is also a symbol for a decimal number. It will be from 0 to 9. And there is also we can say also it is a dot, because if we say about the just look at this example, 92 point, it is a point 92.75 92.75. So what it is? It is like it is in dot. So 92.75. We can say also this point is also the symbol of an decimal number. There is also we have symbols of the Hindi language like e. We have like this all these numbers, all these symbols. We have also a symbol of an empty language, of an empty string, we can say, and sorry, empty language, empty set. We not actually we will not say any word, any string or a language. We will say an empty set, and it is denoted by a symbol of a phi. sorry, and it is denoted by a symbol of a phi. So this is all about the alphabet. There is another concept called a string or a word. It is a finite sequence of alphabets. If we know that if there is a word, it is a finite sequence of an alphabet. It can't be an infinite sequence of an alphabet. Now look at this ABC. This is we have word. This is also a string of a binary number. This is also a string of an English number. This is also a string of an decimal number. So now look at what is length of this string? Total number of alphabets in the word. How many words is present in an how many alphabets is present in a word? It is called as the length of an string. So there is also called as a empty string. Its length is 0. Empty string means there is nothing. There is a string of a length 0. It is denoted by the epsilon symbol. Epsilon symbol, or it is we can say like this symbol, and there is also a symbol called a lambda for it. It is a denotation symbol for this empty string. Now moving over to the next page. Okay. Now look at the we are saying about it. What is the length of this an empty string? It is a 0. If we want to concatenate this empty string with just sorry, this is a dot symbol. So suppose this is a string S. If we want to concatenate it, concatenate means joining it before the empty string. So it will result also a S. We can also join it at the end because it is length 0. So no effect will be on the given string. As if we will concatenate it at the end or in between the words or at in the end. So all the results will be like this. All the results will be like this. There is also we can say this is sigma star. It is also known as the universal language. It is a set of all string, including empty string formed using this alphabet. This is the symbol for an alphabet. Any alphabet denotation symbol. It is alphabet for it is a denotation symbol for any languages, any alphabet of any language. So now look at our next part. What is a language? Language is a subset of a sigma star. What I have to say, what I have told you about is sigma star. It is a universal language. So universal language means it includes all types of languages. So if we say about there is an English languages, or there is an Hindi languages, there is an decimal number languages, binary number languages. So what it will be? It will be a subset of it. We have learned about this concept. What a subset is. So this is a let me write here. What it is a. It is just write me here properly. It is a universal language. Now look at this. What it is? It is a universal language. It is a universal language. Now look at this. If we have I think you are not able to see it properly because of its font size. So now look at this. Where we have a string x, y. We have a string like this x, y, w. So it is not a valid string. Because it is not a valid string, because it not includes in any language. It is not a It is not a valid string. It is not a valid string. So now look at this example. There is a word called, there is a string is called as home, which is a valid string of an English language because it is an Hindi meaning. It is an meaning actually. There is a residential area, actually residential place. We called it as a home. There is also a word called a work. It is also an valid string. So now look at this. What it points is we can perform many operation on the languages. Suppose we have a language L1 and suppose we have a language L2. Here I am talking about with reference actually with respect to this theory of computation subjects. So now we can actually understand it by taking a simple example. Suppose this is an English language and this is an French language. So we can also perform some operation of an set. Like we can perform an union. There is an intersection of these languages. Union means that all the words including L1 and L2. Intersection means whatever words is in L1 is common and whatever words in L2 they should be common. Actually, they must have an equivalent. They must have an equivalent meaning to each other respectively. So we can also perform an operation called intersection. There is also another operation called a set difference. You might know about it already. This is not our hectic problem. There is also a concept called a set difference. Okay, I'm not writing whole words. This is a set difference. If we assume other language of a, suppose we have an English language like this. Suppose this is our English language. We have so many symbols in the English language. Like this, we have a space also. We have some special symbol also, including the alphabets. We have these alphabets. Then we have some special symbols like we also put a space like this. We have also put this exclamation mark. We also put this in the double quotes. So English language also includes many special symbols, uh, including this alphabet. So now look at the sentence of an English language is also a string. Whatever sentence just take an example. I study regularly towards. This is a sentence of an English language. So it is also a string. What it is? It is also a string. Now look at this part. Now look at our next part. What is grammar? Just I have to change the pen color so you will not get confused with the concepts. There is a word called a grammar. What it means? It is a set of rules to provide valid strings in a formal language. Suppose we have an language L1. It is also we can say it as a formal language. So there is a set of rules which forming its string actually. So this is a formal language. What it is? It is a formal language. So there is a in this language we have a set of rules. We have a many set of rules. We have many set of rules. So this set of rules is known as grammar to providing valid string of a particular language or in a particular language. Both are the same thing. This is a set of rules. Sorry. What? There is a set of rules. This set of rules is called as a grammar for a given language. Now there is also a concept called a substring. What is sub? It is a substring is a subset of a string. Suppose we are given with this string A, B, C, D, E, F. Suppose we are given with this string. Now look at this part. Suppose with these two symbols combinedly we saying we have called it name is as a variable x. These two symbols CD we called it as a variable name y, and these two symbols EF we called it combinedly as a variable name z. Sorry, as a z. So y is a subset of, or we can also say it is a subset of this whole string. We are saying it as a s. So we can say y is a substring of this s string. Actually, this is a whole word containing sol symbol. Y is the part of a symbol which including only two symbols C and D. So we can also say u. Now look at this. U is actually there is a y. So I just put here y. Just wait. Okay. Y is a substring of a v. Y is a substring of a v if there exists x xu, if there exists x y, sorry, so y is a substring of a, okay. Now look at this, what we have said is a string, we have named it as a s. So y is a substring of s if there exists, if there exists x, if there exists, if we concatenate this x y and z combined together, then we will give, then we will, if we concatenate it in a sequence, then it we will give our original word what it is. So what it is a, we will say y is a subset of a, or it is a substring of an s. Now look at this, there is also a prefix. It is similar to our English language prefix. What it is now? Now look at this. U is a prefix of, actually, okay. Now look at this. What we have said x is a prefix of x is a prefix of x. X is a, now look at this. What is a prefix? X x is a x is a prefix. X is a prefix. Sorry, I am facing some problem while writing it. Just wait. I just type it, so it will be easy. I will type the sentence. Just wait. Now look at this. Okay. I will type the sentence. Let us see. Okay. Now look. See what am I saying here? Y is a prefix of s if there exists if there exists x, if there exists y is a prefix of x if there exists x, sorry, if there exists x such that if there exists x such that yx is equals to s, yx is equals to s. Now look at this. What am I saying here? I am saying here what this statement is meaning. Y is a, sorry, just let me undo it. How can I do it? Just wait. What is, okay, now look at this. I just write again what it is now. Just wait. After, okay. Now look at this. Y is a prefix of x if there exists x, such that yx is equals to s. Now see what it meaning, what it saying. Okay, now look at this one. Y is a prefix of s such if there exists x such that yx, if yx is equals to s means our given string of a whole words, complete words. So y is said to be prefix of this x. Sorry, y is said to be prefix of this s. This is the simple meaning of it. Now moving to our next page. What it is now? Okay. Now look at this. Now look at this part. Okay, just wait. Just I have to wait. Okay, I've selected and okay, I'm expanding it. Enough it is. Now look at this. What it means. Concatenation of a string is also a sequence. Suppose we have concatenated this string x and y dot x, which is giving us to our original, which is giving us to a string s of containing all words. So this is also a sequence. What it means. Now look at this our next topic. What it is? It is a topic which is a finite automata. From actually we have talked about automata so many times. What it is a machine. We can also say finite machine or a finite automata. Now look at our first. What is a operation we can perform? There is an operator on an alphabet and a languages. We will see what it means actually. With the help of examples. Now look at, there is an power of an alphabet. We know that this is the denotation symbol for the alphabet. There is an alphabet. Actually, this is what it is. I have to just change the pen color. Okay. Now look at this. What is it? It is a binary alphabet. What it is? It is binary alphabet. It is alphabet of a binary number. We have only two symbols in this, 0 and 1. So if we talk about its power, then sigma to the power 0 is equal to empty string. What it means? This is the symbol for an empty string, and this is the word for denotation of an empty string. It is a epsilon symbol. What it is now? It is an epsilon symbol for denotation and empty string. Sorry. Now look at this. There is a sigma to the power 1. What it means? We have only alphabet of a single length. It is 0 and 1. Empty string is a you may know it. What we told about an empty string. It is a string of an length 0. Length of an empty string is equals to 0. So this is a string of a length 1. We have only two symbols 0 and 1. Suppose we have this power sigma to the power 2. Here what we have the exponent as a 2. So what it is? Sigma into sigma. What it is? We have 2. Actually we will apply here Cartesian product here. Now look at this. How we will apply it actually. There is a, suppose we have this 0 and a 1. Suppose we have this 0 and a 1. We will apply Cartesian product here. Because here alphabet, here we have sigma to the power 2. So we are applying Cartesian product one time, actually one time here with the given alphabet. So what it is? 0 is mapped with 0. So what it will be? it will be result into a 0 and 0. Then there is a 0 and a 1. It will be result into in 0 and 1. Similarly, this will result into in 1 0. This will result into in 1 1. So what it will be? It will be 0 0 0 1 1 0 1 1 of a length 2. If we talk about the sigma to the power 3, then there will be, then this is what it is now. This 000 is known as a string. What it is now? A string formed using this alphabet. How many times we have to take the Cartesian product? Actually, we have to take, this is the one time and this is the second time. If we have a power of an n, then we have to take n minus 1 Cartesian products of it. So we will get the length as its power number is same. So we will get as a 0 0 0 0 0 0 we have already we have applied a Cartesian product. So 0 0 0 0 0 1. Now look at this 0 1 0. It is here 0 1 0 1 0 0 1 0 0 1 1 0 1 1 1 0 0 1 0 1. It is here. It is now look at this 1 1 0 1 1 0 and the triple 1 1 1 1. So this is the power of an alphabet. This is the concept all about power of an alphabet. There is a word or a string. Suppose we have, this is the generalized form for it. This is the generalized form for and power of an alphabet. This is a this is a this is a this is a generalized form for it. Suppose we have to be sigma to the power k, then length of the word will be equal to k. There is a word such that this is the symbol. We can also put it as a bar, at a straight bar. This symbol is meaning as a such that we have a sigma to the power k is equals to, we have a word such that length of the w is equal to k. W are the words using form this sigma. This is the our given alphabet symbols. Okay. Just wait for 10 seconds. Okay, now continue. Now moving to our next page for the next topic. What it is now? It is a clean closure. There is actually there is some terminology for TOC. We will say what it means actually. Sorry. This is a word called in. This is a word called in clean closure. What it means, we will see it. Clean closure means it is talking about the universal language. Suppose we have the sigma star like this. This is for the universal language. What for it is? It is a universal language. So universal language contains the alphabets of an all powers. It is also the alphabet of a 0 power. It is also the alphabet of a 1 power. This is the union symbol. There is a sigma to the power 0 union, sigma to the power 1 union, sigma to the power 2 union. It's going on up to infinite times. So this is the universal language. It is also contain an empty string which is denoted by the symbol epsilon. So it will contain all the string. This is the string of a length 1. This is the string of a length 2. This is a string of a length 3. It will contain the string of a length of an up to, we can say it can be up to an infinite time. How we can denote it mathematically in some easy way. Now look at this. There is a union sigma to the power I, where I is greater than or equal to 0. So what sigma? Sigma is a, we have only two symbols. It is actually a symbol on a binary alphabet. Now there is also now look at our next concept. There is a, actually this is the term positive closure. Clean closure means there is a sigma star. Positive closure means sigma to the power plus. What it is now? That was a star symbol. This is a plus symbol. What is sigma to the power 1 union, sigma to the power 2 union, sigma to the power 3 union? It is going up to like this. How we can write it in a mathematics in a easy way? Union sigma to the power I, where I is, sorry, union sigma to the power, union sigma to the power I, where I is greater than and equal to 1, where I is greater than and equal to 1. There is a sigma which has only two alphabet. It is 0 and 1. Sigma, what will be sigma plus is equals to, what it means? We also called it as a positive closure. What we called it as a, we called it as a positive closure. What it will be? It contains the string of a length 1. It will start from the length 1. While in the case of an, now look at the, while in the case of an clean closure, it is also including in empty string. Clean closure excluding the empty string. It will not contain the empty string. How we can write it? There is a word such that, this is a symbol for a such that, there is a length of a word is greater than or equal to 1, and W is a word formed using input alphabet. This is the symbol for an input alphabet. It means how many symbols we have for a particular thing. Now look at some, there is a basic property for it, clean closure and positive closure. It is actually very simple. Actually it is very trivial property. Just now look at it. Sigma star is a union of positive closure, union of empty string. So it is a clean closure. So there is also a, if we intersection the clean closure and the positive closure, then it will result into the positive closure, because positive closure exclude the empty string. So there is a result will be positive closure. If we union it, it will result into an clean closure. Then there is a, if we concatenate it, then there is also a result in a, this is a concatenation. Concatenation means joining the two string. First this string will be present, and then after this string, this string of these input alphabets will be concatenated. Concatenation means, I will write here one more time. It's a joining. What it means? It's a join. It's a join of two words. It's a join of two symbols or two words. Example of a languages. Suppose how we will define it. Language, we already told you about it. Language is a subset of an universal language. We can also set it as a universal language or a clean closure. So there is a sigma, it is a 0, 1. There is a language L1 which is equal to universal language. There is a language L2 which is equal to positive closure, and positive closure is a subset of it, because sigma star contain an empty string and the all string having length greater than and equal to 0, and it will contain the string having length equal and greater than equal to 1. So this is an example of a languages. Now moving our next page, it means next topic. There is a actually what it is now. Okay, what it is a page number 15. Yeah, next page number is 19. Just wait. I think something is missed here. Okay, where we have on this. Okay, now just wait. I will end my video here. I will continue. I will continue from the next topic in my next video. Thanks for watching. If you really liked it, if you really find it this is help, if you really find it this is very helpful for you, then like it and subscribe my channel for this type of video and share it with your friends and family members. Thank you. Thank you guys.